Welcome to our video about vector addition, a crucial idea in math and physics. In this video, we'll explore vectors, why they matter, and how to define them.
By the end of this video, you'll know exactly what vectors are, how to work with them, and why they're so useful in the real world. So, let's get started.
Before we start, let's quickly review our compass directions. You see, in this topic, we often refer to north, east, west, south, as well as northeast, northwest, southeast, and southwest.
North points towards the top of our screen. East is to the right, west is to the left, south is on the bottom. But it doesn't end there. We also have northeast, northwest, southeast, southwest, covering all the spaces in between.
So what are vectors? Well, they're like arrows that shows direction and magnitude. Let's break it down. Vector A and vector B represent different quantities, like forces or velocities. We want to find the result of combining them.
To add vectors, we put them head to tail. It's like connecting the dots. The result is a new vector. Let's call it R. See, we join the start of A to the end of B, and that's where R points. Simple, right? Now, let's see this in action. Imagine you're running 35 meters east, and you rest for 20 seconds. And then again, you run 25 meters east. What is your overall displacement? To find your displacement, add these vectors. Head to tail, so the vector A is 35 meters plus vector B, which is 25 meters. So 35 plus 25 is simply 60 meters to the east. The result is the vector R, which represents your overall displacement. But what if the boy changes its direction to the north after he takes a rest? So, we will imagine that after the boy runs 35 meters to the east, and after he rests, he runs 25 meters to the north. What is his final displacement? Since we have created a right triangle, and the displacement or the hypotenuse is the missing value, so we will use the so-called Pythagorean theorem, which says that a squared plus b squared is equal to c squared, and the c represents the hypotenuse, and a and b represent vector A and vector B. To get the value of c, we will substitute the value of vector A and vector B. So the equation is 35 squared plus 25 squared equals to c squared. 35 squared is equal to 1225, and 25 squared is equal to 625. 1125 plus 625 is equal to 1850. Get the square root of both sides to cancel the squared in c, and the square root of 1850 is 43.01. So the displacement of the boy is simply 43.01 meters. But how to calculate the direction of the displacement of the boy? We need to use a SOHCAHTOA method. In this situation, we will use a TOA, which means tangent theta is equal to the opposite over adjacent. Let's substitute the value. The adjacent will be the x value, and the opposite will be the y value. The x value is the vector A, and the y value is vector B. Therefore, tangent theta is equal to 35, which is the vector A, over 25, which is a vector B. The result is 47.38 degrees to the east-north. So the direction and the displacement of the boy is 43.10 meters and 47.38 degrees east-north.
Have you wondered, what if there are multiple vectors? How we can get this final distance and angle of the direction of the displacement? In this part, we will discuss the adding vectors using the component method. So take this real-life example. A young boy named CJ is going to the school. He was riding a motorcycle and got off the motorcycle. After he got off the motorcycle, he walked heading south. He travels a distance of 3 meters in the south direction. As CJ reaches the school pathway, he spots his friend, Arwen. Realizing he borrowed Arwen's umbrella, CJ decides to return it before going to class. He walks 8 meters in a direction that is 30 degrees southwest and reaches Arwen. They exchange greetings, and CJ returns the umbrella. After returning the umbrella, CJ continues his journey towards his classroom. He walks 10 meters in the west direction, and he walks an additional 1.5 meters in the south direction, and arrive at the school building. So, let's see the top perspective of the vectors. First, we will create a Cartesian plane. We will start at the origin and put 3 meters to the south, 8 meters with an angle of 30 degrees southwest, plus 10 meters to the west, and lastly 1.5 meters to the south. First, we will get the dy and the dx value of 8 meters with an angle of 30 degrees. Dx is equals to cosine 30 times 8 is equals to 6.93. Meanwhile, dy is equal to sine 30 times 8, which is equal to 4. Next, we will create a table and we will put all the given values. Dx represents the x and dy represents the y value. Get the summation of dx and dy, and the result is the summation of dx is equal to negative 16.93 and the summation of dy is equal to negative 8.5. To get the distance of the displacement, we just need to use the Pythagorean theorem. So the equation will be the summation of dx squared plus the summation of dy squared is equal to the r squared. R represents the distance of the displacement. Substitute the equation, and it will be negative 0.93 squared plus 8.5 squared is equals to r squared. Negative 16.93 squared is equal to 286.62. Negative 8.5 squared is equal to 72.25. 286.62 plus 72.25 is equal to 358.87. Get the square root of both sides, and 358.87 will be 18.94. 18.94 will be the distance of the displacement. To get the angle of the direction of the displacement, simply we just need to solve the formula of tangent beta is equal to the summation of dx over the summation of dy. The summation of dx is equal to negative 16.93 and the summation of dy is negative 8.5. So, negative 18.93 over negative 8.5 is equal to 63.34. So, the direction is 63.34 degrees southeast. The displacement of the boy is simply 18.94 meters and 63.34 degrees southwest. That's how vector addition works. By understanding vector addition, we can analyze and describe real-life situation in coordination, making it valuable concept in physics and various other scientific fields. And that's all. Thank you for listening.